That was Evergreen, made popular by Barbra Streisand and written by Paul Williams. Let's see. of The Wind Beneath My Wings by Larry Henley and Jeff Silbar. Okay. And here we go with Somewhere in Time. Thank you. Is it 7:30?
Not yet.
Oh, 3 minutes. 3 minutes. Okay. Kim Robertson. Oh,
Thank you very much, Kim.
all
What a
welcome. Have
lovely,
a good evening, everyone. And happy
thank you.
stargazing. Okay. Yeah, thank you, everyone.
Am I coming through? Yeah,
Yes.
I apologize. Sorry, Kim. I should have said thank you too. I do say thank you. I was greeting some folks. We actually have the hall filling up a little bit, which is good to see. Anyway, welcome everybody. This is the June meeting of Orange County Astronomers, if you can believe it, the 6th meeting of 2024. I mean, we're almost halfway through the year. I mean, it's passing quickly. And I have, before we get to the main program, I have some really good news that has me far more excited and optimistic about our outreach program than I've been for quite a while. And that is, we have a outreach coordinator. And are you going to come up here? I'd like to introduce him. Yeah, this is Martin Christensen, and he has agreed to take over the program. He worked extensively with Jim Benet. He's very familiar with how Jim had handled things. He's got the same, the values. He really wants to see the program succeed on the same terms that Jim wanted. And Martin, would you care to say a few words?
Yes, we do need a few more volunteers for our outreaches that I have scheduled coming up. I have one a week from today that we could use one more telescope. We have 3 volunteers, including myself, signed up for it. I'd like to thank Melody and Jason Oxman and John Cray. I don't know how it's pronounced, Creigh, for agreeing to come to the outreach in Brea. There's another one scheduled for August 20th. It's going to be at Crystal Cove. Anybody been down there? The Grunion will be running, as they like to say. And Erin Andriata of the Crystal Cove Conservancy decided to contact me as soon as she found out that I was a new outreach coordinator and asked for the OCA to bring some telescopes down. The site is barely suitable, however, for telescopes. There's a sizable bluff in the north and east of the sky that will block off part of the sky. Polaris should be visible.
No, we want volunteers.
Yeah, Polaris should be visible. Yeah.
Anyway, so if you want to volunteer, please contact Martin.
Contact me at martin@ocastronomers.org or outreach@ocastronomers.org. If you want to volunteer. We also have two outreaches scheduled for January 2025 at schools already. This software package on my computer, and it runs okay. I've had a couple of errors come up while I was trying to use it, but I think they've been pretty much patched up now. Jim has updated some of the software to correct some of those errors, I believe. He's very kind and intelligent with it. He's a very valuable resource to our community. Let's all give him a round of applause for being the OCA outreach coordinator for so long, and now for passing the baton to me.
Hear, hear. Well, thank you very much, Martin. And I have a feeling that we're going to be hearing from a lot more schools once they realize we have a viable program again. Thanks a lot. And without more ado, let me turn it back over to the regular program for tonight. And I believe next up is our announcements with Kyle.
Awesome. Here we go. Here we are. All right. Welcome, everyone. Welcome, new members. We're glad to have you. Your membership badges will be on the whiteboard right next to where Barbara is. And if you're not attending the meeting in the next couple months in person, eventually the badges will just be mailed to you. Please remember that coffee, donuts, and water are available for all of you who are in person tonight up by the library entrance for $1 each. Star parties. The ANSYS Star Party will occur next on July 6th. We have Astrophysics Special Interest Group meeting on June 21st. The beginners class July 5th. And the next OCA board meeting is July 28th online. Both Astrophysics and Special Interest Group and the beginners class meet at the Heritage Museum. You can check the website for more information on all of these events.
Kyle, could I add something on that?
Yeah.
We will be doing the annual Star Barbecue at the August Star Party at ANZA. So please, I realize we've got more than a month from now, but mark your calendars and plan to be out there.
Awesome. The next beginners class will be the How to Use Your Telescope class. If you have a telescope and are looking for some help learning how to set it up, use it, feel free to bring it out to this class. It'll be a hands-on class where you'll be able to get some help using your scope and getting it up and running so that you can explore the sky. As mentioned earlier, Martin Christensen is our new outreach coordinator. You can see the email there to contact him. And here's the current schedule of events as of a few days ago. Again, that was already discussed, but feel free to reach out to him if you want to volunteer or learn more. We're still looking for a social media coordinator. If you are willing to help with that, please contact Reza. This role can has a lot of flexibility in what it looks like in its totality, but we would like to increase our presence through our Instagram, Facebook, and Twitter accounts. So if you'd be interested in helping out with that, please contact Reza. The Adopt a Scope program is up and running. It's been running for a little bit. If you're interested, you can see here on the website how to get to the page about it. We have a bunch of information there, along with a sample adoption agreement and list of the current inventory available. Head to the website if you'd like to learn more about that. The Serious Astronomer newsletter. Dave Fisher is always looking for new content to go in those monthly newsletters. If you have any items of interest, such as articles, images, trip reports, advertisements for equipment for sale, etc., please reach out to him and he'll review those items. Please remember that everyone always gets a hard copy mailed to them unless you opt out. the Serious Astronomers always available to all club members in an electronic format on our website. If you would like to opt out of receiving a mailed copy, please email Charlie with those instructions. Again, unless you opt out, you will still receive the printed copy. Friendly reminder to everyone who uses the ANSA site. If you're the last one to leave the site, please remember to lock up the ANSA house, ensure all the windows are closed so no critters get in, and make sure to close the gate to the site in order to make sure the site is secure. Also, please remember to help with weed clearing along your pad, and if you can help with the common areas such as the observatory area, ANSA house, football field, etc., that would all be very much appreciated. Right. The next general meeting will be July 12th. And I will turn it over to our WhatsApp presenter for that. Thank you.
Thank you very much, Kyle. That was a wonderful announcement, as always. Just because this is the first time we have a new WhatsApp presenter, sorry, Lonnie, to interrupt. Let me say a sentence about this. So we have for tonight Lonnie from United Astronomy Clubs of New Jersey, who's a space artist doing the WhatsApp presentation to us. Please join me in welcoming him. Lonnie.
Thank you very much. Thank you, Kyle, and thanks to Reza for making this possible. I'm honored to participate with your club. So I'm going to be sharing my screen. Let me know if you do not see what I'm talking about. And right now I'm going to begin. What's up for the next, part of this month through the middle of July. Am I coming in loud and clear?
Yes, all good.
Very good. We're looking at a screen capture from a free program I'll be talking about later, showing the sky from Chapman University at 21 hours. 21 minus 12 for you mathematicians out there is 9 p.m. when we're looking at the Scorpion, the Teapot, and very high in the sky, the Corona, which is important for a new event coming up, and Hercules. But let's talk about this in detail. We'll start, and I'll be speaking quickly. So please interrupt me if it's not clear. June 20th, we're coming up on the solstice at 2046. That's 1:46 p.m. your local time. And that's when the sun is highest in its path on the Earth's orbit, drawn out into space, above the Earth's equator, drawn out into space. Earth's equator runs right through the belt of Orion. Why are we seeing a winter constellation? Because it's summer. In the daytime, we see the winter stars. We've got phases of the moon every month to look forward to, full and new. One of them is terrible for seeing faint objects, and that's full. And the new moon is wonderful for seeing faint things like nebulae, that's gas clouds, star clusters, galaxies. You can get a lot of information from moongiant.com about the moon. I don't work for any of the websites I mentioned tonight. So I don't work for Moon Giant. You get the current phase. You can get beautiful calendars that you can print, showing the principal phases. You can turn on illumination, level, phase names, but I'm showing only the main phases. So early at the middle of this month, right now, is a great time to see details as the sun rakes across the moon, 90 degrees. Look at the terminator between light and dark during the first quarter phase when the sun sets, or as soon as the sun sets, right on into the evening. If you like to get up early in the morning to do that, you want to look at the last quarter phase, and that's the end of this month, or first quarter moon and last quarter moon, again, repeating the beginning and the end of next month. Full moon, absolutely terrible time to see anything except maybe planets and bright stars. In the morning sky, we have a nice alignment, like occultation is not quite right. That's when something covers. These are a meeting of the moon near Mars and Jupiter, and it happens twice, this month and next. So looking at July 1st, the moon is a thin crescent. By July 3rd, it's a thinner crescent. as it passes Mars, Uranus, which we can't see here, the seven sisters are Pleiades and Jupiter next to the Hyades. These are two star clusters, old and newer. Hyades is the face of Taurus, the bull. Mars is near Uranus. I mentioned that's July 15th, middle of next month. You can find Uranus right near Mars, which is right near the Pleiades, the seven sisters. And if you have sharp eyesight, you might see more than seven. I see six generally. If you have a pair of binoculars or telescope, you'll see more. This is 5 in the morning on the 15th of next month. Chance to see the innermost planet Mercury, July 22nd. It's elongated east of the sun. So when the sun sets, east is to the left, upward near the main sign of spring, now disappearing at 8:30, 20:30 at night on 7/22. And that's the main and the tail of Leo the Lion. Look for Mercury. You'll have a brief chance. And finally, for events July 31st, a minor meteor shower, the Delta Aquarians, named for Aquarius, the water carrier. It looks exactly like a guy carrying water, right? I'm nodding. I'm not nodding. I'm shaking my head the other way. Look near the star Delta for the radiant point where the meteors stream out in all directions. Unfortunately, the peak is about 16 per hour. If you live in a suburban area, as I do, you'll see probably no meteors. But do look in August for the Perseids. That's a major shower. The peak, July 30th, even though the meteors are seen over an extended period. And these are probably debris from a comet Mach-Holtz. We're not sure. A big event. We don't know when this might happen. Anytime up through September. The Blaze Star, T, Corona Borealis in the crown. It's a double star, and material is being drawn out of a giant red star falling onto an accretion disk, accreting material around a white dwarf, tiny compact star with the mass of a star and the size of a planet. We've seen outbursts before in 1946, the same exact pattern repeated in 2018 and this year, which means we are going to see an eruption becoming about 600 times brighter from invisible magnitude 10 to magnitude 2, which is like a star in Cassiopeia, the W, visible to the naked eye. So let's look for that star. Let's simulate the sky right now with Stellarium, a free program. We're going to look for the Blaze Star later this year, anytime starting now through September, next to Epsilon in Corona, next to the big H for Hercules. I'm going to use this free program to do it. You can download it. You can run it off their website. You can run it on a mobile device. And Stellarium shows no stars right now. Why? Because it's 1948 and 39/40 seconds. 19 minus 12, 7:48 p.m. Is it dark out? No. So we can cheat in Stellarium. We can change the time to 20:48. How about 9:48 at night? Everybody still awake? We're seeing the sky as you would on a planisphere, a circular star map. Your gift shop probably sells one like this, but in Stellarium, we can remove the distortion by mapping the whole sky down onto a flat piece of paper by zooming in. And if you do, you'll notice a familiar, famous group of stars made easier to find if we cheat and draw lines as you would see on a star map. This is part of a constellation. Tail, head, claws, the Great Bear, Ursa Major, and this is not a constellation, it's a part of one. 8 stars, count them, 8. 1, 2, 3, 4, 5, 6, 7. Hard to notice sometimes that in the bend of the handle is a visual double star, Mizar and Alcor. Not related, not held together by gravity, an accidental alignment. If you want to use a technique we amateurs use to find other stuff, star hopping, go 5 times the distance of the 2 pointer stars, which is 5 degrees, or about the size of your fist held at arm's length. 1, 2, 3, 4, 5, you'll just miss the North Star Polaris in the Small Bear, Little Dipper. And then the constellations besides these that you can always see, they're up all day long and night, right? So you'll always see the W, Cassiopeia, the queen, the house, Cepheus, the king, her husband, Draco, dragon, big and little dippers. You'll see them 24 hours a day, right? Nope. You won't see them in the daytime, even though they will be up. But the further away you look from north, the faster things move, the more they move through the sky and they rise and set. So if you look in the west, right, go out tonight, look for the letter W, you're going to see it? No. You can turn the cardinal points on and off in Stellarium, and you can do a lot to customize. I made the moon 4 times bigger than it normally looks. You'll see the lion, Leo, disappearing in the west. You'll see the stars of spring disappearing. And if you move to the south, the most interesting part of the sky, you'll find the signs of the zodiac. Leo is 1, Virgo, Libra, scales. Scorpion kind of looks like what it is. You'll see star colors, reddish Antares, the heart of the scorpion, Alpha Scorpio. Scorpius, excuse me. The astrology name is Scorpio. Scorpius, the astronomy name. And the teapot, we amateur astronomers call it the teapot. It's actually supposed to be a centaur, half man, half horse, with a bow and arrow. Sure, it looks just like it. Here, let me take the picture off. Looks just like a centaur, right? But if you can find this constellation this summer, and if you look later on at night when it is darker, you might see the Milky Way galaxy, which I've turned off because it's too bright. So why don't we cheat a little bit and don't limit our magnitude. There's some sky illumination here. Whoops. Lots that you can do to customize. You'll see a stream of light, not here, but in the real sky, the Milky Way, like a river of milk. That's our galaxy. This time of year is a good time to look for other galaxies. You'll want to look in this neighborhood for star clusters for nebulae. What's a nebula? It's a gas cloud. This one's visible to the naked eye if you go to the Anza site, right? If you go out into the desert where it's nice and dark, no city lights, you might see a tiny cloud. I'm going to zoom in as you would see it in binoculars or a high-powered telescope. The Lagoon Nebula, glowing red from hydrogen gas in its natural color. Dark dust hiding the gas behind it. Nearby, the famous Trifid Nebula, glowing blue from the light of hot young stars, much hotter than our sun. Red hydrogen gas. These wonderful objects, there's so many of them that you can find, but we're going to have to cut our talk short and just look up high in the sky tonight to end this part of our talk with the crown, where we look for the nova later this year. Where? Right here, right by these faint stars. Next to Epsilon in Corona Borealis. The star will be almost as bright as the brightest of these stars. Next to it, the famous hero of legend, Hercules, holds a famous deep sky object, deep in the sky, thousands of light years away. So that's what we call them. Nebulae, gas clouds, clusters of stars. This one looks like a globe. So astronomers have given it the very unimaginative name, globular cluster. And this is the most famous, most easily visible from the northern hemisphere. Not the biggest. There's one even lower in the sky, which you might see from Florida. But this is M13 in Messier's catalog. M13. And it looks like it's moving slowly away from my pointer. Why? What's moving? If you have a telescope without a clock drive and you focus in on something, it's going to move out of your field of view because the Earth is rotating. So look for M13 amongst the keystone stars of Hercules. We're running out of time, so I do want to have some time to conclude my talk, but I urge you to go out, look north to get your bearings, start in the west, sweep eastward to see the main constellations of summer, and then look over for the summer triangle. Summer triangle, 3 bright stars, 2 of them have been in science fiction. Vega in Contact, the movie and book, and Altair in the old movie Forbidden Planet. Try it yourself. Stellarium's free. The sky is free. Your eyes are free. And they are also the best equipment to see meteor showers. I'm going to conclude with some references. Whoops. Pardon me, technical difficulties. Here we go. And if you want to get started, binoculars is a good way. If you get bored using them for astronomy, you can use them for birds, you can spy on your neighbors. You can get large binoculars for a little bit more. They used to be much more than this. They've come down to about half their original price. Beginner telescopes are also fairly affordable. And for people who like to gather more light and spend a little more money, Dobsonian is an excellent design, designed by a person named Dobson who lived in California. I'm reporting to you live from New Jersey, the other side of the United States. And more complex designs are using multiple things like mirrors and lenses. Good references, Sky and Telescope and Astronomy magazines are still in print. They're online, you can subscribe, and the amount of stuff you can get for free on their sites is incredible. But if you forget everything else I've said tonight as I end my talk, try to remember space.com. It's easy. And you can see all sorts of things like news, the search for life, and space flight and science. Free apps, they're all free. Most of them are free. I like Skyview and Stellarium. Find out about them from space.com. And Celestial lets you fly through space to see what things look like on other planets or on their moons. Free. There's lots of free stuff out there. I mentioned Stellarium. You can install it. You can run it off the website. You can do it on any mobile device. And a quick review, look for these main things in the evening. Summer solstice is in the daytime. The moon, Mercury, as the sun sets. A meteor shower, maybe. If you like to get up early, the moon passes Mars and Jupiter. Here's how you find me. I've been honored to be a guest. And thank you, Reza, for inviting me. You can find me at astronomyinmotion.com, and you can work my 3D model of Mars for a very small fee, or use the HD free sampler at Mars at your fingertips. Thank you.
Thank you very much, Lonnie. Covering everything from what we can see in the sky, the events, and the equipment that we can buy, and also the apps that we can get. That was wonderful. And we're going to have you in the future. So looking forward to more WhatsApp presentations from you. Thank you very much.
You're most welcome. Thank you, everyone. Sure.
Great. So now at this point, it's time for me to introduce the main speaker of the night, who's the Astronomical League's vice president. He founded the National Young Astronomer Award in 1991, received the G.R. Wright Award for Service in 1998, and holds the League's Master Outreach Award with over 550 public programs to his credit. He just completed observing a rare exoligmus, which is 2 total solar eclipses separated by 54 years and 33 days. The first one is in March 7, 1970 in North Carolina, and the next one just a few months ago, April 8, 2024 in Lake Placid, meaning that the paths of both eclipses are relatively congruent. And since 1960, he has observed 3,900 discrete objects in the sky, including 2,900 deep sky objects and 2,250 galaxies and 32 quasars. Please join me in welcoming Chuck Allen. Chuck.
Great. Thank you very much. Appreciate it. Is my audio okay, Reza?
Yes.
Okay, fantastic. First of all, I want to thank you for inviting me. It's a real pleasure to always join significant clubs around the country for opportunities like this. Just one little quick word about the Astronomical League. We are bigger and stronger than we've ever been. We're up to 24,000 members in 310 clubs. We have a trust fund with $1.3 million in it now. We're spending about $14,000 on youth awards each year. We have conventions scheduled all the way through 2029, and we're looking to have one in Bryce Canyon in 2025, which is not a bad drive for all of you in California. And we may be having a mini convention in Hawaii in the very near future, which might be of interest as well. Our observing program division's up to 77 different observing regimens now, and we've expanded into not only visual and binocular observing, but also imaging as well. So with that, I will proceed into tonight's program, which is about extreme astronomy. And with that, I'm going to share screen here. And okay, give me just 1 second. Nice if I could see the, okay, here we go. One second, please. Okay. Everyone see that okay?
All good.
Excellent. Thank you. All of us like records. I think everyone is probably impressed by the Burj Khalifa, 2,722 feet. It might be interesting to know that a fellow by the name of Eli Breeding once sustained 82 Gs in a rocket sled in New Mexico in 1958. We're pretty impressed with Hikam El Garouja's mile record, which has stood since 1999 of 343.13. And there's always Zach the Macaw, who managed to open 35 canned drinks in 1 minute's time, although that record perhaps doesn't impress quite as much. But there are a lot of records in space travel and astronomy as well. And a lot of them are incredibly interesting. And so we're going to visit those tonight. It's kind of easy listening because there's no real development from one to another. They're all different, but they're all unique in their own way. And what we'd like to start with here, and let me, be nice if I could advance it. There we go. We're going to start with temperature. What is the coldest place that's ever existed in the universe? Now, I know your first thought will be the depths of space, but you have to have material in order to have temperature. And so the coldest place in the universe that's ever been achieved that we know of, the record holder, was actually at the University of Bremen in Germany. And on August 30 of 2022, Christian Deppner and his ZARM team managed to cool down some rubidium atoms using a process of magnetic entrapment, where they would turn the magnets on and off, causing these atoms to lose energy progressively and become something called a Bose-Einstein condensate, which I'll show you a short video about here in just a second. And in doing so, they just needed to take the condensate and rid it of any extra energy it was getting from Earth's gravitational field. So they dropped it down this 120-meter drop tower to eliminate that. And they got the rubidium atoms down to a temperature of 38 trillionths of a degree Kelvin of absolute zero, that close. So here is a little video about the Bose-Einstein condensate process. what about the coldest place in the universe now? Well, that ostensibly is at the center of the Boomerang Nebula in Centaurus. It's 5,000 light years away, and gas is exiting the core of the nebula at a rate of 310,000 miles per hour. As a result of that, tremendous cooling has taken place, reducing the temperature to 1 degree Kelvin at the center. The hottest place by comparison is a quasar that many of you have probably observed because it can be seen in an 8-inch telescope, and that is the brightest of all the quasars in the sky, 3C273 in Virgo. At the boundary between the accretion disk and the event horizon of that black hole, at the center of the quasar, is the hottest place we know of in the universe today. And that temperature is 18 trillion degrees Fahrenheit. Now, this quasar is 2.44 billion light years away, and those of you who like observing quasars, which I've gotten into recently, should look for one in Draco that has a light travel time to you of 9.6 billion years. And it's readily findable because it's in the same field with 2 8th magnitude stars. Well, what about the question of observatory records? We all know that the largest refractor in the world is still the Yerkes 40-inch. It's an F19. That tube is 60 feet long. It has a doublet at the top that weighs 485 pounds. And of course, the observatory is located in Lake Geneva, Wisconsin. For a while there, it looked like the whole place, which is highly atmospheric, was going to be razed for condos, but that was finally saved. And Yerkes is still a wonderful place to visit. The largest single aperture reflector in the world is the segmented 409-inch mirror of the Gran Telescopio Canarias in the Canary Islands. It has 4 times the light gathering power of the 200-inch Hale telescope at Mount Palomar. However, we can go slightly larger if we combine apertures, such as occurs at Mount Graham. There, the twin 330-inch mirrors of the Large Binocular Telescope give an effective aperture of 465 inches, which is about 56 inches more than the Canary Island telescope. And once again, this produces about 4 times the light gathering power of the Hale telescope. Soon, however, probably by 2028, we will have the extremely large telescope in Chile. And that will have a 1,547-inch segmented mirror and 60 times the light gathering power of the 200-inch at Mount Palomar. The largest radio telescope in the world is at Jinkei Village in Guizhou Province in China. It's a ½ kilometer across, 500 meters. That's called Eye of the Heavens, and it went into operation in 2016. As far as the oldest observatory known, the oldest confirmed observatory is a calendar circle at Nabta Playa in Egypt. It has been confirmed to be 6,500 years old. This was confirmed by Professor Malville. However, there are some scientists who believe they have found an older one at Werda Yuang in Australia, an Aboriginal calendar circle that may be as old as 12,000 years, although this has not been confirmed yet. Well, what about impact structures, astrobleams as we call them on Earth? And the largest one that has been confirmed is the Vertafort Dome in South Africa. It's 190 miles in diameter, which is roughly twice the size of the Chicxulub crater from the KT impact that killed the dinosaurs. Only this one occurred a lot sooner. It occurred a lot further back in time, rather, 2 billion years ago. It's estimated that the impactor that created the Vertafort Dome was 14 miles in diameter. There has been some thought by some scientists that there may be a larger one in Antarctica that may be 300 miles in diameter, but again, this has not been confirmed at all as of yet. The largest known impact structure is actually in our little system here. It's on the moon. It's the South Pole Aitken Basin. The impact occurred as a result of a 121-mile or 120-mile wide impactor that struck about 4.2 billion years ago. It created a 1,600-mile wide impact basin that's about 4 to 5 miles deep. But as with other records that we've been discussing, there are some unconfirmed reports out of Tokyo that there may be a larger one on Ganymede. Some Japanese scientists in 2020 detected a large series of circular furrows that indicate a possible impact structure that is 4,800 miles in diameter. That's bigger than the diameter of Ganymede. That would have been created by a 90-mile wide impactor by estimate. Again, not confirmed. Well, turning now to space flight, some of you may find some of these particularly interesting, I hope. We'll start with the space flights that do not involve humans, and we'll talk about the first vehicle ever to pass the Kármán line. This is the first object, man-made object, ever to reach space, and that was a V2 designated MW18014 that was launched from Peenemünde in Germany in October of 1942. Of course, this rocket had nefarious purposes, as you know. Nonetheless, it was the first vehicle to pass the Kármán line. The first vehicle ever to reach orbit was Sputnik 1 on October 4th, 1957, a dramatic event that I remember watching from the back porch area of a neighbor's house here in Louisville. Actually, Sputnik 1 was not visible, but the upper stage booster that put it into orbit also entered orbit and was easily visible flying overhead. It was very, very dramatic and stimulated a great deal of sudden activity in the American space program, as I'm sure you're aware. The first spaceflight fatality was a Russian dog named Laika aboard Sputnik 2, just a month after Sputnik 1. Laika was sent into orbit. Unfortunately, the heating or cooling system aboard the spacecraft failed and it overheated, and Laika perished as a result of that. The worst space-related disaster in history involved the military space program and not the manned space program, and it occurred at the Baikonur Cosmodrome in 1960. And it involved this rocket that you see here, which was a liquid-fueled ICBM, meant, of course, to deliver nuclear weapons. And they were trying to get it ready to launch in October of 1960, just before a big celebration in Moscow, which was, of course, the October Revolution celebration. And Nikita Khrushchev was very interested in bragging about the success of this launch. General Mitrofan van Netelen was supervising the operation to try to get this missile working and get a successful launch off before the celebration. Unfortunately, there was an electrical problem on the second stage. So without defueling the rocket, General Netelen went out and went up to the second stage, roughly where you see the crossover there in the middle of the picture. Now, when the general goes, the colonels and the majors and the captains and the lieutenants and all the technicians have to go because they've got to show as much interest as he does. And so there were a lot of people around that rocket when they began tinkering with the second stage. Unfortunately, they accidentally ignited the second stage rockets right on top of the fully fueled first stage. The result was, 92 people died in the explosion, including some of their top rocket scientists and countless technicians, and 49 were injured. The slide that I accidentally misplaced here was the first amateur vehicle to reach space. That occurred in 2004 with the civilian space exploration team's launch of the Go Fast rocket, which reached a height of 72 miles. It was launched from the Black Rock Desert in Nevada. Okay. What about the first unmanned landing on another celestial body? That occurred in February of 1966 when the Russians landed Luna 9 on the Oceanus Procellarum. Landed at about 14 miles per hour, a little harder than they had hoped. It bounced, but managed to begin broadcasting pictures back to Earth using something called radio fax, which is how newspapers used to transmit pictures to one another in those days. As a result, Jodrell Bank Observatory picked up the radio fax transmission and broadcast these images worldwide, which the Russians probably intended to happen. The first unmanned landing on another planet occurred, also a Russian feat, in 1970 on December 15th, when its Venera 7 lander descended to the surface of Venus. The parachute shrouds, however, began to melt just before landing, and the parachute failed, causing the spacecraft to strike the surface at 37 miles per hour and tilt rather badly. Nonetheless, it survived for 20 minutes and broadcast images and temperature readings and pressure readings back to Earth. We learned then that the surface temperature of Venus was 887 degrees Fahrenheit, and the pressure 90 atmospheres. That is the equivalent of being 3,000 feet deep in the ocean. Our first asteroid landing occurred as a result of the Near-Shoemaker's mission to 433 Eros. We landed on the asteroid on February 12th of 2001, when the asteroid was 158 million miles from Earth. And this was a surface photo taken from the satellite region, the saddle region rather, of the asteroid. The most distant unmanned landing that we've ever had was a result of the Cassini mission and the Huygens lander. The Huygens lander touched down on Titan, Saturn's moon Titan, on January 14th of 2003, when it was 885 million miles from Earth, the furthest landing ever. And here's a video, hopefully with sound, that will show you something about that landing. Our first comet landing was a result of the Rosetta Philae mission, which landed on Comet 67P Churyumov-Gerasimenko on November 12th of 2014. This was a journey that took 10 years. The Rosetta mission did a flyby of Earth and Mars and 2 other asteroids en route to the comet, and managed to get some incredible images of snow-like effects near the surface of the comet. There are also streaks in these images from cosmic rays. The most distant object that we've ever visited with an unmanned spacecraft was originally designated 2014 MU-69, or Ultima Thule. It's now been renamed Arrokoth, and of course it was the second target of the New Horizons mission after Pluto. It was 4.15 billion miles out when the New Horizons mission passed it. This is a contact binary between two trans-Neptunian objects. The total length is 13 miles by 9 miles. The fastest spacecraft ever was the Parker Solar Probe, which achieved a speed of 394,000 miles per hour on September 27th of last year. It reached a distance of just 4.5 million miles from the sun, meaning that the sun would have subtended a 9-degree angle in the sky. That's roughly the size of the bowl of the Big Dipper. It would look like a 3-foot beach ball at a distance of 18 feet. It will get even faster on a perihelion passage this year when it will exceed 400,000 miles per hour relative to the sun. Well, Voyager 1 has established many records, and 2 of them I'm going to talk about here. One, of course, is the furthest photo ever taken of the Earth, the pale blue dot photo made famous by Carl Sagan. This was taken when the vehicle was 3.7 billion miles out. That's further than Neptune, and it was taken on Valentine's Day in 1990. Voyager also is the furthest man-made object from the Earth. It lies today at 15.1 billion miles. That's roughly 5 times the distance of Neptune, and it's taken 47 years to get there. That's about 1/2000th of a light year. It's traveling at 38,000 miles per hour and not slowing down much at all now. If it were headed toward Proxima Centauri, which it's not, but if it were, it would take about 70,000 years to get there. It's expected to lose power next year, however. Now turning to human spaceflight, we look at the first human beings ever to enter space. The first was, of course, Yuri Gagarin of the Soviet Union on April 12, 1961. He did 1 orbit. The landing was rather strange. Yuri's capsule, as it descended through the atmosphere, he opened the door and jumped out and parachuted to the ground. This was planned at that time. When he landed, Vostok 1 landed somewhere else, but they did not then have a perfected method for landing on land, so he had to parachute down. He landed in a field where a woman was tilling the field. He was wearing his space helmet and an orange jump spacesuit and began walking toward the lady, who was quite shocked by the sight. When she saw that it was a human being, she said, "Where do you come from?" And he said, "A ship." And she said, "But there's no water near here." And he said, "Well, it's a ship from the sky." So that must have been a magic moment for her. The first woman in space was Valentina Tereshkova, and 2 years later did 48 orbits, also, of course, a Soviet cosmonaut. Yuri Gagarin died at age 34 in 1968, just 7 years after his orbital flight in a training plane crash. Valentina Tereshkova, however, is alive today. She's 87 years old. The first person to do a spacewalk and demonstrate that extravehicular activity was possible was Alexei Leonov of the Soviet Union aboard Voskhod 2, and he did his spacewalk on March 18th of 1965. The first human spaceflight fatality, unfortunately, was also a Soviet cosmonaut, Vladimir Komarov, on April 24th, 1967. By then, he was flying in a vehicle called the Soyuz 1, which was supposed to land with a sudden burst of rocket fire just before the impact to soften the landing. Unfortunately, the parachutes on the Soyuz failed, and he crashed into the Earth at very high speed, and a fire ensued in the spacecraft. He was killed on impact, however. Yuri Gagarin knew that the Soyuz 1 was afflicted with countless structural flaws and wanted to take his good friend Komarov's place on this mission. Of course, being a national hero like John Glenn, they didn't let him fly, and Komarov took the flight and perished as a result. The human speed record belongs to the astronauts of Apollo 10, Tom Stafford, Eugene Cernan, and John Young. Just before Apollo 10 returned to Earth, before it made atmospheric interface, it achieved a speed of very nearly 25,000 miles per hour. That's a speed record that holds today. It was set in May of 1969. The first man landing on another world, we don't need to dwell on this too much. We're all aware of it. The Apollo 11 landing on July 20th, 1969, which occurred at about 1:17 p.m. California time. The human altitude record is now 54 years old and has not been broken in all that time. It was set on tax day in 1970 by the astronauts aboard the ill-fated Apollo 13 mission. That's the one where the service module's oxygen tank exploded. We got the astronauts back alive, but in the process, they looped around the moon in what's called a free return trajectory that took them 171 miles above the surface of the far side of the moon. At the very day, April 15th, when the moon was at apogee. As a result, they reached a distance of 249,205 miles from the surface of the Earth, and as a result, set the human altitude record that remains today. The first and only human fatalities to occur in space above the Kármán line are 3 Soviet cosmonauts who in 1971 died aboard the Soyuz 11 spacecraft. They were preparing for re-entry when their cabins suddenly decompressed, killing all 3 of them. Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev perished in that. Their bodies were recovered. No other humans have ever lost their lives above the Kármán line. The longest stay on the moon belongs to the Apollo 7 astronauts who spent 3 days and 3 hours in 1972 in December on the surface of the moon. Eugene Cernan and Harrison Schmitt set that record. Harrison Schmitt is seen here with me, but that's only because he met with everyone at our convention in Albuquerque. He was one of the last people to leave the banquet hall. He took so many pictures with people, one of the friendliest people I've ever met in my life. Incredible who you can meet at some of our conventions. The gentleman on the right is Ronald Evans. He was, of course, the command module pilot who remained in orbit during the Apollo 17 mission, and he is tied for the record with the most orbits of the moon at 75. Who is he tied with, you ask? Well, he's tied with 5 mice named Phi, Phi, Fo, Fum, and Fui, who were aboard the command module. The longest space mission ever belongs to Valery Polyakov, another Russian. In 1995, he stayed in orbit for 437 consecutive days over 7,075 orbits of the Earth. And the most time in space is a record being set even as we speak by another Russian, Oleg Kononenko, who as of today has completed 1,009 days of his life in space, and he's still going. He's scheduled in the current mission, which is his 5th mission into space, to reach 1,101 days total, which will be 3 years and 6 days of his life spent weightless. The most space missions belong to Jerry Ross and Frank Chang Diaz, who are both American astronauts. They've been in space 7 times each. Well, let's look at the solar system for some records. What's the highest mountain in the solar system? I know what you're thinking, but you might be wrong. It's actually Rhea Silvia on the asteroid Vesta, which rises 74,000 feet from the plane of an impact structure on this asteroid. From base to summit, it's 74,000 feet tall, which eclipses Olympus Mons on Mars by about 2,000 feet. If we look at all of the significant mountains in the solar system, we see Mount Everest at 29,028 feet, which is actually eclipsed by Hawaii's Mauna Kea if you ignore the water. From base to summit, Mauna Kea is the tallest mountain on Earth at 33,500 feet. Olympus Mons, huge, the size of Arizona, 72,000 feet above the average plane of Mars. Rhea Silvia, from base to summit, a little bit taller. The most active, volcanically active world that we know of is Jupiter's moon Io. It's under a constant state of eruption. Here you see a volcano called Fashtar Patriae, which is spewing out a 230-mile long plume and is spreading material as far away as 430 miles. It's spewing out silicate lava. The largest storm is not the Great Red Spot on Jupiter. The largest storm we've ever observed was the Great Springtime Storm on Saturn, which erupted in December of 2010 rather, and extended until August of 2011. This storm covered a total of 1.5 billion square miles. That's about 8 times the surface area of the Earth. The storm was 186,000 miles long and approximately 9,000 miles wide. An incredible event that amateurs could easily observe during that time. The tallest known cliff anywhere is Verona Rupes on Uranus's small moon Miranda. Miranda is only about 240 miles in diameter and has very low gravity. And this cliff is about 63,000 feet tall. That's about 12 miles. Now, you might think because of the low gravity and the fact that it would take 12 minutes to fall off this cliff, that it might be a fun ride. After all, after 10 seconds, you'd only fall 13 feet. And after 30 seconds, you'd only have fallen 35 feet from the precipice. Unfortunately, by the time you got to the end of the ride 12 minutes later, the relentless increase in gravitational acceleration would take you to 124 miles per hour, meaning that you would regret your decision. And turning to the universe, the nearest star to us, of course, is Proxima Centauri. It's a red dwarf that orbits 2 sun-like stars, Alpha Centauri A and B. It's a long, lazy orbit of 550,000 years, so Proxima will stay the closest star to us for quite some time. It's 4.25 light years away. That's about 25 trillion miles, or roughly 8,300 times further than Pluto. Its diameter is 124,000 miles, so this is about how big Proxima is compared to our sun. And another way to think about its size is just to imagine that you stuff 2 of them between the Earth and the Moon. Interestingly, Proxima has at least 2 planets, possibly a third. We know of Proxima Centauri D and B, which have 5 and 11-day orbits. There's a Proxima Centauri C that is disputed with a 5-year orbit. So, as of now, the closest exoplanet to us is Proxima Centauri B when it reaches the side of Proxima in the direction of the sun. That holds the record. This planet, Proxima Centauri B, is slightly larger than the Earth, and it lies in Proxima's habitable zone, meaning temperature is right. Unfortunately, red dwarf stars are flare stars, meaning that this planet gets bathed in intense radiation periodically, making life highly unlikely. Well, how close are we to a supernova remnant? Well, fact is, we're right smack in the middle of one. One was created about 10 to 20 million years ago in the Pleiades moving group, and has expanded to a diameter of 300 light years. And as it has expanded, our sun has moved right into the middle of the bubble. So we're right in the middle of a supernova remnant. It used to be called Geminga, by the way, but it's not called that anymore, just the local bubble. The most sun-like star is one you can see naked eye. It's magnitude plus 5.5, 18 Scorpii. It's 45 light years away. And look at how it matches the sun. Same mass, same luminosity, same diameter, same temperature and color, same rotation rate, and same age, almost identical. So if you want to know what the sun looks like from 45 light years away, here's your chance. The largest apparent diameter, as seen from Earth, of a star belongs to the star R Doradus, which has an apparent diameter of its disk of 57 1,000ths of a second of arc. That's slightly larger than Mira or Betelgeuse, and considerably larger than the apparent size of Pluto as seen from Earth. These, again, are apparent diameters that we're talking about as seen from Earth. The smallest known planet is planet B around the star Kepler-37 in Lyra, about 215 light years away. It's roughly the size of Earth's moon and slightly smaller than our smallest planet, Mercury. It's in an 18-day orbit around its star and very hot, about 800 degrees Fahrenheit on its surface. The largest known planet, is ROX 42Bb, which you see on the right side of the screen here. It's orbiting a star in Ophiuchus, about 440 light years away, and it's 9 times Jupiter's mass and about 3 times Jupiter's radius. Turning next to the closest known black hole to us, it's one called Gaia BH1. It's 1,560 light years away, and it's in a bound system with a sun-like star. They orbit each other around a common center of mass about every 186 days. The black hole is very small. It has a mass of about 10 suns and an event horizon of about 34 miles in diameter. The most planets around a sun, well, that's one that we held the record for until we demoted Pluto. And with that, we fell into a tie with Kepler-90. Kepler-90 is in Draco, about 2,800 light years away, and it, like the sun, has 8 planets that we have detected. What about the furthest known moon, the furthest known natural satellite? Well, it actually is a moon orbiting a planet called Kepler-1623b in Cygnus, about 8,000 light years away. What happened was the transit method detected the planet that it orbits, responsible for this first dip you see here in brightness of the star. But then there was a secondary dip of considerable measure that indicated a following natural satellite of the star. And as a result, it was detected. And it's not only the furthest known moon, it's also the largest. It's 48,000 miles in diameter, making it larger than the planet Uranus. The hottest known star, that honor belongs to a Wolf-Rayet 102 in Sagittarius, about 9,400 light years away. It's a small star, about 60% the diameter of the sun, and has a surface temperature of 378,000 degrees Fahrenheit. That's about 38 times hotter than the surface of the sun. The fastest spinning pulsar, which is in that little yellow box that you see there, is 18,000 light years away and is in Sagittarius and is spinning 716 times per second. This was determined from its radio pulses. That means that at the equator, it's spinning at 24% the speed of light, about 156 million miles per hour. The largest known star is one called, it's located right in these tick marks here in the constellation. It's in the Large Magellanic Cloud in the constellation of Dorado. And it's called, perhaps I should emphasize, whoa, G64. It's 1,540 times larger in diameter than our sun. It lies 160,000 light years away and is the largest known star that has been confirmed. Fastest moving star, by the way, this is how big WOA G64 is in relation to the orbits of Earth and Mars. Pretty large. In fact, 1,500 solar radii is generally considered to be the limit of how large stars can actually exist. The fastest moving star orbits the black hole at the center of our own galaxy. It's called S4716, and at perihelion, it achieves a speed of 18 million miles per hour, about 8% the speed of light. It's this bright one here as it loops down around the black hole, which is roughly where the cursor is. If you can see it, it picks up enormous speed. The furthest known exoplanet is not one in the Milky Way. It's now believed to be in Andromeda, M31. It's called PA99N2. It's about 6 times the mass of Jupiter, and it was detected because of a micro-lensing event. This is where one star moved in front of another, brightening the star. The first peak you see on the chart at the upper right. And then there was a second brightening indicating that the light from a planet was being microlensed. And so this detection is considered to be the discovery of an exoplanet in another galaxy. The closest galaxy to us is actually one that is entwined with us. It's called the Canis Major Overdensity, or dwarf galaxy. Its core is about 42,000 light years from the core of our own galaxy. And when we look at it from Earth, we see it in the direction of Canis Major. The two-mass survey picked it up because of an extraordinary number of red giant stars found in these bands that were looping around our galaxy. It's about 1 billion stars all in all. The fastest spinning star that's not a pulsar is WR142, which lies in Cygnus. It's spinning at 2.2 million miles per hour at its equator. It's about 4,000 light years away. This is an image of the loneliest galaxy that we've ever found. It lies in Pisces. It's called MCG 0102015. It lies in the middle of the Pisces-Perseus void. It's 295 million light years away, but the stunning thing about it is there are no other galaxies within 100 million light years of it, despite the picture making it look like one is. The largest known spiral galaxy is the Condor Galaxy, which is NGC 6872 in Pavo. It's 522,000 light years in length from the end of one spiral arm to the other. Compare that to the Milky Way, which is 100,000 light years across. This is about 200 million light years away from us. The largest known galaxy in terms of mass still appears to be IC 1101 in Virgo, 1 billion light years away. It's estimated to have 1 trillion stars, roughly 500 times more than the Milky Way has. It has a halo that would extend past both the Milky Way and Andromeda if it were located in between the two. M81 is superimposed in this picture in the lower left just for comparison of size. The largest known galaxy in terms of the extent of its stars, though, and the one that Wikipedia lists currently as the largest known galaxy, is one in Centaurus, ESO 38376. It has a length of 1.76 million light years. It's 17 times the length of the Milky Way galaxy, and is 800,000 light years across. It's located in Centaurus, about 654 million light years away. However, if you consider the jets and lobes created by black holes at the centers of galaxies, Alcyonus in Lynx may hold the record for largest galaxy. Now, this is not by extent of its stars. This is by the extent of the lobes created by those jets. It is 16 million light years from one lobe to the other in this galaxy. And what about BAT 99-98? It's somewhere in that cluster in the middle. No one's got a good image of it, but it holds 2 records. It's sitting in a cluster in the Tarantula Nebula in the Large Magellanic Cloud, about 160,000 light years away. And this one star holds 2 major records. It's the most massive known star, 226 times more massive than the sun, and the most luminous star known, 5 million times more luminous than the sun. The largest known black hole, Phoenix A. It's 5.8 billion light years away. It has a mass of 100 billion suns. That's about 24,000 times the mass of the black hole at the center of the Milky Way, has a diameter of 366 billion miles. That's about 100 times the distance from the Earth to Pluto. The most massive galaxy cluster is El Gordo, the fat one. It's in Phoenix, 7 billion light years away. The galaxies in this cluster account for over 3 quadrillion stars. The largest known structure in the universe was detected by virtue of an unusual number of gamma ray bursts found in a stream extending through 5 constellations, Hercules, Corona Borealis, Lynx, and Boötes, and Draco. And it is called the Hercules Corona Borealis Great Wall. Its dimensions are 10 billion light years in length, 7 billion light years wide, and it extends over 1/9 the width of the observable universe. The brightest known object is a quasar in Pictor, which shines with 500 trillion times the luminosity of the sun. It has 17 billion solar masses, and the accretion disk is falling into the event horizon at the rate of 1 solar mass per day. Its distance is 12 billion light years. Well, the furthest known object, and this is the final one, the furthest known object until very recently was a galaxy in sextants that the JWST determined to be at a light travel distance of 13.46 billion light years. Now, bear in mind, the universe is 13.8 billion years old, so we're looking now to within 300 million years of the beginning, at a time when it was not thought galaxies really had time to form yet. Today, this galaxy lies at 33 billion light years, but just 10 days ago, the JWST found the new record holder, the galaxy JADES GS Z14.0. This galaxy is small. It's only 1,600 light years in diameter. It's estimated that its light has taken 13.53 billion years to reach us, and today lies at a distance of 34 billion light years. To give you some perspective on that distance, because of the expansion rate of the universe, that means that we and it, in whatever form it has today, are now separating at more than twice the speed of light. And with that, I will stop sharing and invite any questions that any of you have. Those are the records. Thank you.
Thank you very much, Chuck. What a fascinating talk, and each slide merited a wow itself. That was great. Thank you for sharing that with us. So now the floor is open for questions. But before, I think it's good if I ask you, can you tell us about the process that you go preparing this and keeping it updated, Chuck?
Murderous. Every time I give this program, I have to review roughly, I would say, a third of the records, especially the ones involving the universe. The spaceflight records don't change very often, although they do change. Kononenko's record is still ongoing. JWST keeps finding galaxies that are slightly further away back into the dark era. And so you have to keep on your toes. I gave a program, this same program, at the Mid-States Region Convention of the League just last week, and had to update Kononenko's record. Excuse me, the galaxy distance record had just been set 4 days earlier. So you just have to go through every one again, and they do change.
Thank you. Thank you. So let's go to the audience in person. Are there any questions?
Does anybody have any questions? It looks like they're thinking about it.
Yeah, I almost hope there aren't. I almost hope there aren't too many, because it's very hard if people start asking me, well, how did they measure this or how did they measure that? To research that deeply into so many records is very difficult. So sometimes I'm unable to give in-depth answers to those, but I'll do my best.
I see a raised hand.
Sure.
Charlie? The question is, what is the largest spaceship, and does Elon Musk's endeavors factor into this yet?
Well, you mean, could there be a record added to this? Yes. I mean, I have to sort out lots of records that I don't find very interesting, and maybe some of these records you didn't find very interesting, but you have to draw a line somewhere. I'm sure the one you saw launched the other day is the largest, certainly the most powerful rocket that's ever been launched. So that would hold the record. I suppose I could add that.
I think you're allowed artistic decision making regarding what you include and what you don't.
Yeah.
Okay, any other questions? Yes, sir. I'm sorry, which object was that? Mm. The question is you talked about a galaxy that was 300,000 years old, and he wanted to know what the redshift on that would be.
14.
Cool. Yeah.
It's actually in the title of the galaxy. It's called
Uh,
Jade's GSZ 14.0. So that's the Z number right there.
it's good to have a shortcut.
Yeah.
Um,
And that's 300 million years after the Big Bang is what we're seeing there, not 300,000.
mhm. Any other? Yes, sir.
Describe the diameter of the event horizon line plotting. Did you remember what it was you said earlier?
The question is regarding the largest black hole that you mentioned,
Yes.
and regarding the event horizon, you gave a diameter for it, and he wanted to know if you could recall what that was.
The diameter is 366 billion miles.
Great, thank you.
Mhm.
You want to try some of the online questions, Raisa?
That's the kind of black hole you want to fall into, because you get a nice long ride before any spaghettification occurs. A very long ride, in fact.
So Chuck, can you put that in perspective? 66 million miles, you said?
366 billion
360.
miles. Yep.
So that's further than the distance from the sun and the earth. Am I right?
It's 100 times the distance between the sun and Pluto. So when all of you, I'm sure, have heard that if you fall into a black hole, you eventually get to a point where your feet are a considerable percentage closer to the singularity than your head, which stretches your body, because that means your feet are being stretched with higher gravitational acceleration than your head. And it stretches you into a string bean and kills you. But a black hole this size, if you enter the event horizon, you don't feel anything. You're just floating toward the singularity for a very long period of time before you get to a point where your feet are substantially closer than your head, or whatever orientation your body's in. So if you want to fall into a black hole, fall into a big one. There's actually, I actually read an article the other day. Some scientist somewhere, an astrophysicist, has postulated that we may live inside a black hole, which would mean that the universe, there's nothing to back this up, but he postulated that we're inside a black hole of such size that, yeah, we, the observable part of our universe, may be falling toward a singularity, but it's having no effect because it would take forever to get there, or a very long period of time to get there. But it's just one article that one scientist postulated, and there's nothing to back it up at all.
And there is also a question about tailoring your presentation to kids and adults. So is this the adult version? Do you have a kids version? What is different?
I do. The kids seem to like the space travel part of it better, in my experience, and they're not so interested in pulsar spin rates, and probably you weren't either. I thought about pulling some of those slides from it, and I probably should, but I think maybe some of the large galaxies and hottest stars could be made, could be tailored to kids, but the space travel seems to be more interest to them.
Okay, great. Barbara, any other questions in person?
Any others here? Nope, everybody still seems to be with very rapt attention, though, and we certainly thank you very much. That was a really, really great presentation.
Well, my pleasure.
I hope you
And
can-
thank you for inviting me, and I hope you'll invite me back again sometime. I'd love to visit with you again.
Thank you.
Of course,
you.
of
Thank you.
course. So thank you very much. I would like to also thank our audience online and in person for attending. Please do check on our website on the calendar, ocastronomers.org, for all our upcoming events. And with that said, I say good night to everybody and wish you great times ahead. Bye-bye now.